Alright, here's our second test. We're just doing PEMDAS. I have to do what's inside parentheses. We treat absolute value like parentheses. So inside I must square first. So I get negative 5 minus 9, which is negative 14. The absolute value of negative 14 is positive 14. 14 minus 20 is negative 6. Inside the parentheses first, 13 minus 16 is negative 3. Now I must do the exponent before I do the multiplication, so I'm going to square it before I multiply. So that's negative 3 squared, which is 9. 9 times 2 is 18. 3 minus 18 is negative 15, plus 7 is negative 8. F of negative 2 means you're plugging negative 2 in for the x. So I plug it in for the x, and I just simplify. Order of operation again. So I square it first, and then multiply by the 2. That's how I got 8 minus 1 is 7. 1, or h of 2, this is h of x. So that means take the 2 and plug it in for the x, and I get out a 1 for my y. H of x equals negative 1 means I'm plugging in negative 1 for my y, my output. So that means I'm going down here, and I have to see what value I get, and that's negative 2. G of x equals 11. So that means my output is 11. So this whole thing is going to be replaced with an 11. So that's why there's 11 here. And then I just solve it, and I get my negative 3. For every input, there has to be one output. I plug 2 in, I get out 3. That's consistent. I plug in 3, I get out 5. That's consistent. I plug in 4, I get out 3. 4, I get out 3. Yep, consistent. So that means I have a function. If I plugged in 0, I could get out 1.5 or negative 1.5. Not consistent. I need only 1 to come out to be a function. My domain is my possible x values. So my x can go all the way down to negative 4, but not equal negative 4. And it goes on forever because of the arrow. So that means all the way to infinity. My range goes all the way down to negative infinity, all the way up, and stops at 3. My domain, all the way negative infinity because of that arrow, stops at 3 because of that dot, but can equal the dot because it's a filled in circle, so it's equal to 3. Range, all the way down to negative 1, all the way up to 4. And it can equal both of them because if I plugged in negative 2, I could get out negative 1. If I plugged in 0, I could get out 4. So I have each one of these squared because of the parentheses. So that's 9. X to the third squared is x to the 6th. That's where most of the mistakes I saw happen. And then y squared. Nothing to do to this guy. So I end up with 2 times 9, which is 18. X to the 4th times x to the 6th is x to the 10th. Y to the 3rd times y to the 2nd is y to the 5th. Most mistakes happen just on this little part, reducing this 20 over 15. The first thing I did is square each one of these parts. It's inside the parentheses here. That's how I got the 4, the a to the 4th, and the b to the 2nd. And I simplified the top. 4 times 5 is 20. A times a to the 4th is a to the 5th. And b times b squared is b to the 3rd. B to the 3rd divided by b to the 3rd, that's 1. A to the 5th over a, 1 would cross out, and that would leave me a to the 4th on top. This is 4 times 5. This is 3 times 5. The 5's would cancel out, leave you the 4 over 3. Subtract 18 from both sides to get the 3x by itself. Divide by 3, and just leave it as a fraction. B. Subtract 2x to get this 4x over here. Subtract 23 from each side, so now I have my x on one side, all the other numbers on the other side. Divide by 4, and this is just 2 times 15, this is 2 times 2, the 2's would cancel out and leave you the negative 15 over 2. Combine like terms, that's 2x minus 5x is negative 3x. Many people wrote 3x. Got to keep track of your negatives. I added 4x to both sides, it gets me a positive x. Add 10 to both sides and I get a positive 22. Combine like terms, 12 minus 18, that's negative 6. 3 plus 2 is 5. 7 minus 8 is negative x, or negative 1. And then when I added 6 to both sides, I got a 0. When I added x to both sides, I got a 6. 0 times 6 is 0, so x equals 0. Adding one little figure here, there, and there. So that's 4 of them being added each time. It's growing by 4, so to go backwards, I would take away 4, and that leaves me the 3 there. So it starts off at 3 and is going up by 4 each time. And then find figure 50, you just plug in 50 for the x to find the y. And the table is just 0. The 0 figure is at 1, 2, 3 of them. First figure is 7 of them. You just count them up and you can fill them in.